You have seen your reflection thousands of times. Left swaps with right, and that is all a mirror does. Except serious physicists now argue the whole universe may work like that glass. On the far side of the Big Bang, a mirror cosmos may run backward in time, filled with antimatter holding a reflection of you. The case rests on a symmetry nothing has ever broken, one impossibly heavy invisible particle and two signals that rose out of polar ice the wrong way. Start at the glass. Run the film of the universe backward and you hit a wall 13.8 billion years deep. A first flash hotter than anything physics can name, where every equation we own is supposed to tear like wet paper. In 2018, 3 physicists published a calculation in one of the most scrutinized journals in science, claiming the equations do not tear at all. They pass through. And what sits on the other side, in their mathematics, is this universe again, reflected. Time running the other way, antimatter where matter should be, left where right should be. The proposal is called the CPT-symmetric universe, and those 3 letters, C, P, and T, name the deepest symmetry physics has ever tested. The claim is not that the Big Bang was the beginning. The claim is that the Big Bang was a mirror, and that our universe and a backward-running anti-universe stand facing each other across it, like a reflection and the thing reflected. Hold your own reflection in mind as we go, because over the next 2 hours that image will stop being a metaphor and become a physical theory with hard numbers attached, numbers that telescopes and neutrino observatories are testing right now. Here is the mechanism, at first working level, before any history and before any names. Cosmologists can wind the universe backward with confidence, because the expansion we measure today runs on equations that work in both directions. Wind it back and galaxies dissolve into gas. Gas dissolves into a glowing plasma, and in the first moments, everything that exists is compressed into a sea of radiation, pure light-like energy, denser and hotter the further back you look. At the final step, the mathematical size of the universe goes to 0. That point is the singularity, the place where the temperature and density read infinite on paper, and where the standard account says space, time, matter, and the laws themselves simply begin. But what does the equations break down actually mean? It means a quantity in the mathematics becomes infinite, and calculations stop returning answers. It does not mean physicists proved nothing lies beyond. Those are different statements, and the difference is the door this whole theory walks through. Because there is a special property of that early universe which changes the character of the singularity. In its first moments, the cosmos was dominated by radiation, and radiation has an almost magical mathematical feature called conformal symmetry. It does not care about the overall size of space. Light behaves identically in a universe of any scale. You can stretch or shrink the map, and radiation's physics reads the same. So the size going to 0 catastrophe for radiation is less like matter being crushed and more like a map's scale bar shrinking, a change of labeling rather than a physical annihilation. In the technical language, the Big Bang of a radiation universe is a conformal singularity, one of the mildest kinds there is. Latham Boyle, Kieran Finn, and Neil Turok took that mildness seriously. Their move, published in Physical Review Letters in December 2018, was to treat the equations describing the universe's size as functions that can be continued through the 0 point, the way a smooth curve can pass through the origin of a graph without stopping. Picture the simplest version. The curve of y equals x passes through 0. Nothing about the curve ends there. 0 is just a point it crosses, with negative territory on the other side. Their calculation says the size of the universe behaves like that curve. On our side, it grows. At the bang, it touches 0. And on the far side, it opens out again into another expanding universe, except the time coordinate there runs in the opposite direction relative to ours. What would living in that reflected region look like? The honest answer is that nothing about it would feel reversed from the inside, and we will earn that answer properly before this video is over. But first you need to know what the three letters mean, because the entire argument hangs on them. C stands for charge conjugation. It is the operation that swaps every particle for its antiparticle. Electrons become positrons, protons become antiprotons, and every electric charge flips sign. Antimatter is not science fiction. Hospitals use it every day. A PET scan works by injecting a tracer that emits positrons, the antimatter twins of electrons, and detecting the flashes when they meet electrons and annihilate. C is simply the instruction. Swap all matter for antimatter everywhere. P stands for parity. It is the mirror operation, the one you perform every morning without thinking. Flip left and right, invert the spatial directions, turn the universe into its own reflection. Your right hand becomes a left hand under parity. A clockwise spin becomes counterclockwise. T stands for time reversal. Run every motion backward. A planet orbiting one way orbits the other way. A cup shattering on the floor becomes shards leaping together into a cup. Each of these, alone, sounds like a symmetry the universe should respect, and for decades, physicists assumed it respected all three separately. The universe corrected that assumption in stages, and the first correction was one of the great shocks of 20th century physics. In 1956, careful studies of decaying particles hinted that the weak nuclear force, the force behind radioactive decay, might tell left from right. Within a year, experiments with cobalt nuclei chilled to a fraction of a degree above absolute zero confirmed it. The electrons shot out of those decaying nuclei preferentially in one direction relative to the nuclear spin. Build the mirror image experiment, and nature refuses to behave like the reflection. Parity, P, is violated. The universe is not ambidextrous. It has a handedness written into one of its four fundamental forces. Think about what that means for a moment. If you filmed the cobalt experiment and its mirror image, a physicist could tell you which film was the real laboratory. The reflection is distinguishable from reality. And once P fell, the dominoes kept going. Physicists retreated to the combination CP, matter swap plus mirror, hoping the two flips together restored the balance. In 1964, experiments with particles called kaons showed CP fails too, by a whisker, but unmistakably. The universe distinguishes matter from antimatter even after you mirror it.
So what survives? One combination. Perform all three operations at once, swap matter for antimatter, mirror the space, and reverse the time. And every experiment ever conducted says the result is indistinguishable from the original. That triple flip is CPT. It has been tested to extraordinary precision in the masses of particles and antiparticles, in their magnetic properties, in the decay rates measured at particle accelerators, and it has never cracked, not once. And here is the part that separates CPT from every other symmetry in physics. It is not merely an observed pattern, it is a theorem. In 1951, Julian Schwinger's work on quantum fields implicitly contained the result. In 1954, the German physicist Gerhard Lüders and the Austrian physicist Wolfgang Pauli proved it explicitly, and John Stuart Bell, later famous for his work on quantum entanglement, proved it independently. The Lüders-Pauli theorem states that any theory built on the two deepest foundations of modern physics, Einstein's special relativity and quantum field theory, must respect CPT exactly. Break CPT and you break relativity or quantum mechanics themselves. That is why physicists treat those three letters differently from every other symmetry. C can break, P can break, CP can break, T can break, but CPT is welded to the frame of physical law. How hard has nature been pressed on this? Harder than on almost any claim in science. At CERN, the European laboratory outside Geneva, physicists manufacture antihydrogen, whole atoms of antimatter, one antiproton dressed with one positron, and hold them in magnetic bottles for study. Every property they can measure, the light the antiatoms absorb, the energy levels they occupy,
the mass and charge and magnetism of their parts, is compared against ordinary hydrogen, and the comparison is a direct interrogation of CPT, because the theorem demands the twin properties match exactly. They match. To parts per billion and beyond in the sharpest tests, they match. Neutral kaons, the same particles that betrayed CP in 1964, provide comparisons more delicate still, and they match. Not one experiment, in 7 decades of trying, has pried the smallest daylight between matter and its full CPT reflection. What does it mean that nature, which breaks C, breaks P, breaks CP, and breaks T, refuses under any interrogation to break the triple product? Physicists read it as a structural truth. The mirror flip of everything is not a habit of nature, but a load-bearing wall of reality's architecture. Keep that welded to the frame status in mind. It is the entire justification for what comes next. Because now the question almost asks itself, if CPT is the one perfect symmetry of the laws of nature, is the universe itself, as a whole, CPT-symmetric? Look around. This cosmos is made of matter, not antimatter. It runs forward in time, not backward. Taken alone, our universe flagrantly breaks the very symmetry its own laws keep exact at the level of every particle interaction. The laws are balanced. The world built from them is lopsided. Physicists have a name for that situation: spontaneous symmetry breaking. And for decades the assumption was simply that the universe's initial conditions broke CPT, the way a pencil balanced on its tip must fall in some particular direction, even though the laws governing it favor none. Boyle, Finn and Turok asked the question the other way round. What if the universe does not break CPT? What if the state of everything taken in full respects the deepest symmetry exactly, and the reason our patch looks lopsided is that we are only seeing half of the picture? A single glove looks like a broken symmetry. A pair of gloves does not. Their proposal: the universe we inhabit and a CPT-reflected anti-universe on the far side of the Big Bang together form the symmetric whole. Our matter is balanced by its antimatter. Our forward time is balanced by its backward time. Our left is its right. In their words, the universe after the bang is the CPT image of the universe before it, and the pair emerges in the mathematics from nothing, directly into a hot, radiation-dominated era on both sides. What does it mean that the most tested symmetry in physics, applied at the largest possible scale, predicts a second universe? Sit with the structure of that claim. Nothing exotic was added. No new fields, no invented forces, no adjustable dials. The ingredients are the standard model of particle physics, Einstein's gravity, and one demand: that reality as a whole obey the symmetry its laws already obey. The mirror universe is not an assumption of the theory, it is the output. I want to be precise here because this channel does not oversell. This is a minority proposal, a challenger. The dominant account of the early universe, cosmic inflation, remains the working paradigm of most cosmologists, and later in this video we will weigh the two against each other on the evidence, honestly, including the places where the mirror model strains. But the proposal is serious. It is published in the field's flagship journal, and it makes predictions sharp enough to kill it. And the story of how 3 physicists arrived at it, and what an Antarctic balloon may or may not have seen falling out of the ice, is one of the most interesting stories in modern cosmology. Picture a frozen pond on a winter morning. The surface is the present. Skate forward and you move into the future. Now the pond in this analogy has a peculiar geography. Somewhere behind you lies a line where the ice meets its own reflection, as if the pond were pressed against a wall of polished silver. Everything on your side, every ripple frozen into the surface, has a counterpart on the far side of the silver, reversed. The standard story of cosmology says the silver wall is where the pond simply ends, an edge with nothing beyond it. The CPT proposal says the silver is not an edge. It is a mirror, the pond continues through it, and the reflection is another pond, as real or as unreal as the mathematics turns out to demand. Whether that reflection is a genuine place or a bookkeeping device is a question we will confront directly, with Turok's own words, because his answer is subtler than either headline you could write. That subtlety matters, so let me flag it now, early, before the story builds. When a physicist says a mirror universe exists on the other side of time, there are two things they might mean. The strong reading, it is a real place with real backward-living inhabitants. The careful reading, it is a mathematical requirement, a structure the equations need in order to stay consistent, the way your reflection needs to exist in the glass for optics to work, without anyone believing there is a second bathroom behind the wall. The authors of this theory lean, on the record, toward the careful reading, and the theory's testable predictions do not depend on which reading you choose. That honesty is rare, and it is one reason this proposal is worth 2 hours of your attention. If you are enjoying the journey so far, a quiet tap on subscribe helps more of these deep dives reach curious minds, and it genuinely helps this channel keep making them. Now, the man at the center of this story. In 1958, in Johannesburg, South Africa, a boy was born to two anti-apartheid activists, Mary and Ben Turok, members of the African National Congress, at a time when that membership carried a prison sentence. His father served time for his political work. The family lived the resistance, then exile. The boy, Neil, made his way to Churchill College, Cambridge, then to a doctorate at Imperial College London in 1983. His career reads like a tour of the summits of theoretical physics, research at Santa Barbara, a post at Fermilab, the American Particle Physics Laboratory, a professorship at Princeton by 1994, then the chair of mathematical physics at Cambridge in 1997, where he collaborated with Stephen Hawking on the quantum origins of the cosmos. In 2008, he became director of the Perimeter Institute for Theoretical Physics in Canada, one of the world's leading centers for foundational physics, and he now holds the inaugural Higgs Chair of Theoretical Physics at the University of Edinburgh. Along the way, he founded the African Institute for Mathematical Sciences in Cape Town in 2003, seeding advanced mathematics education across the continent his parents fought for. I mention the biography for a reason beyond respect. Turok is not a fringe figure shouting from outside the establishment. He is the establishment, or was, and that is precisely what makes his current position so striking. Because Neil Turok has spent the last decade arguing that his own field has lost its way. Before we follow him there, we should be honest about the belief this video is pressing against. Because you almost certainly hold it, and you hold it for good reasons. The belief, the Big Bang was the absolute beginning. Time started there, space started there. There was no before, and asking about a before is a grammatical mistake, like asking what is north of the North Pole. If you learned cosmology from school, from documentaries, from the great popularizers, this is what you were taught. Stephen Hawking himself made the North Pole comparison famous, and every textbook diagram you have ever seen draws time as an arrow with its tail pinned at a point labeled t=0. The universe, the story goes, erupted into existence roughly 14 billion years ago, and the origin of that eruption is either a mystery or a meaningless question. Was that belief foolish? Not remotely. It follows from taking Einstein's general relativity at face value. The equations of gravity, run backward, predict their own failure. Densities climb without limit, curvature climbs without limit, and at the singularity the theory returns infinities, which in physics is a confession of ignorance. The honest reading for decades was that the beginning is where our mathematics ends, so the beginning is all there is. The belief was reasonable. It was also, this theory argues, incomplete in a specific, checkable way. Notice what the standard picture quietly assumes, that the breakdown of our current equations marks a genuine edge of reality rather than an edge of our understanding. There is a difference between a map that ends at a coastline and a map that ends because the surveyor ran out of paper. The CPT-symmetric universe is a claim that the surveyor ran out of paper.
and that the mathematics, handled with sufficient care, can draw the next page for itself. So how do you handle a singularity with care? How do you get equations to pass through a point where they read infinity? This is the technical heart of the proposal, and it is beautiful enough to explain properly. The tool is called analytic continuation, and mathematicians have trusted it for 2 centuries. Here is the idea in ordinary terms. Some functions are so smooth, so internally constrained, that knowing them in one region fixes them everywhere else. The way you can extend the sequence 2, 4, 8, 16 without being told the rule twice. If a curve is of that special smooth kind, a gap or a puncture in the middle does not stop you. The shape on the near side dictates the shape on the far side. Boyle, Finn and Turok showed that in a radiation-dominated cosmos, the equation for the size of the universe is exactly that kind of function. The size, tracked in the natural time coordinate of light, called conformal time, behaves near the bang like a simple straight line passing through zero. Approach the singular point and the mathematics does not shatter. It glides through, the way the line y equals x glides through the origin, and comes out the other side with its sign flipped. A sign flip on the size of the universe sounds like nonsense, a negative-sized cosmos. But sizes enter physics squared, and what the flip actually encodes is orientation, not magnitude. Cross zero and the natural reading of the solution is a second expanding universe on the other side of the bang, with its arrow of conformal time pointing away from the mirror, opposite to ours. The 2 sheets of the solution meet at the singularity like 2 cones tip to tip. And now the masterstroke, the reinterpretation that turns a mathematical curiosity into a physical proposal. In the 1940s, the physicist Ernst Struckelberg, later championed by Richard Feynman, established one of the strangest facts in quantum field theory. An antiparticle is mathematically identical to a particle traveling backward in time. That is not a metaphor. In the equations of particle physics, a positron moving forward is indistinguishable from an electron moving backward, and every calculation in every particle accelerator on Earth uses that identity daily. Boyle and Turok applied it to the whole cosmos. If the far sheet of their solution has time running the other way, then from our perspective, every particle in it is an antiparticle. The mirror universe is not just time reversed. It is, seen from our side, made of antimatter. And it is space inverted too, the parity flip riding along with the geometry. Time reversed, T, matter swapped, C, space mirrored, P. The far sheet is not merely another universe, it is the CPT reflection of ours, exactly the transformation the deepest theorem in physics singles out as sacredly exact. Here, the theory earns its first equation, and it is less an equation than a boundary condition, so let me give it the way the authors state it. At the bang, at conformal time zero, the mathematical object that defines lengths and directions in spacetime, called the tetrad, goes to zero. The tetrad at time zero equals 0 everywhere in space. And the CPT symmetry then does something remarkable. Of the 2 mathematical solutions for how the universe can emerge from that point, one smooth and one singular and wild, the symmetry forces the coefficient of the wild solution to vanish. In the author's notation, B of k equals 0 for every wavelength k. Picture a guitar string fastened at a bridge. Clamp the string's endpoint and you have not just described the string at one point. You have dictated which vibrations the entire string is allowed to carry forever after. Only the harmonics compatible with the clamp survive. The bang, in this theory, is the clamp. The smoothness of the universe is not an assumption bolted on. It is a harmonic selected by the symmetry of the fastening point. That single move answers a question that has embarrassed cosmology for 50 years. Why did the universe begin so smooth, so uniform, so improbably tidy?
The observed cosmos looks the same in every direction to 1 part in 100,000, and explaining that uniformity is the main job inflation was hired to do. In the CPT-symmetric universe, the smoothness needs no hiring at all. What does it mean that the tidiness of the cosmos might be enforced by a symmetry rather than produced by a process? It would mean the universe's neatness is not an accident of history, but a requirement of law, as different as a beach smoothed by waves is from a mirror polished flat, because polishing is what defines it. Now for the caution I promised, and it deserves its own moment, because a viewer's fair question right now is, do these physicists really believe there is another world back there, with backward stars and backward antimatter people? Turok has answered directly. The mirror universe, he says, need not be real in the classical sense, just as your image in the mirror is not real. The best current interpretation, in his words, is that it is a mathematical device which ensures that the initial condition for the universe does not violate CPT symmetry. He has also offered the most disarming line in this entire literature. The combination of you and your mirror image are more symmetrical than you are alone. And quantum uncertainty guarantees the two sheets are not exact copies anyway. The reflection is statistical, not photographic. There is no other version of you with your memories walking backward through an anti-Earth. Or if there is, the theory cannot promise it. What the theory does promise is stranger and more useful, that treating reality as the symmetric pair, real or bookkeeping, changes the predictions our own sky should obey. Predictions we can check, predictions with numbers. Still, the imagination will not let go of the far sheet, so let us take it seriously for a few minutes and ask the question every viewer is silently asking. If the anti-universe is a place, what is it like inside? Is there an anti-you over there, aging in reverse, remembering the future? Start with the strangest and most certain answer. From the inside, nothing would seem reversed at all. Why not? Because every process an inhabitant could use to define the direction of time, the cooling of coffee, the shattering of cups, the accumulation of memories, runs off the growth of disorder. And disorder grows, on both sheets, as you move away from the mirror. The bang sits at the bottom of the entropy ledger for each side. An observer on the far sheet would experience time flowing from their bang toward their future, exactly as you do, would watch their cups shatter and never unshatter, would remember their past and wonder about their tomorrow. Their physics textbooks would call their matter matter and their direction of time forward. The reversal is entirely relational, visible only from a viewpoint outside both sheets that no observer can occupy. Backward is what each side would call the other, and neither would ever feel it.
Could the two sides meet, signal, or interfere?
No, and the no is absolute in a way physics rarely permits. The sheets touch only at the mirror itself, the singular boundary at the beginning, and every path between them runs through that point of infinite compression. There is no trajectory, no light ray, no message that starts in one sheet after its bang and arrives in the other. The anti-universe is causally sealed, the way the inside of a mirror is optically sealed. You can see the layout implied by the glass, but no hand reaches through. This is why the question of its reality stays so slippery. The theory places it forever beyond visitation, and everything testable about it lives in the constraints it imposes on our side. Then is there an anti-you? Here quantum mechanics steps in with a firm correction. The CPT relation between the sheets holds for the quantum state as a whole, and quantum states fix probabilities, not photographs. The far sheet is our reflection statistically, the same laws, the same particle inventory in reverse, the same large-scale texture. But quantum uncertainty guarantees the details differ, fluctuation by fluctuation, galaxy by galaxy. Turok has said this outright. Uncertainty means the two sides are not exact mirror images. The overwhelming likelihood is that no anti-Earth orbits an anti-Sun. that the far sheet grew its own unrepeatable history from its own quantum dice. The title of this video says a mirror version of you, and the honest fine print reads, a mirror version of your universe, certainly, in law and in ledger. A mirror version of you, almost certainly not in person. And if the far sheet is only mathematics, then not even in principle. The claim was never that you have a twin. The claim is that reality has a balance sheet, and you are an entry on one side of it. Before we continue, consider what you would need to believe for the alternative, the standard picture, to be true instead. You would need the deepest exact symmetry in physics to hold perfectly for every particle process ever measured, and then fail once at the largest scale there is, for the universe as a whole, with no explanation for the failure. That is not absurd. Spontaneous symmetry breaking is respectable physics. But feel the weight of what each side is asking you to carry. One asks for a broken perfect symmetry. The other asks for an unreachable second sheet. Physics has faced this kind of choice before, and the tidier bookkeeping has a distinguished record of winning. And the first number in that bookkeeping is a monster. The 2018 papers came as a pair. The first, CPT-symmetric universe, laid out the mirror. The second, titled The Big Bang, CPT, and Neutrino Dark Matter, cashed it in. Because once you demand that the universe-anti-universe pair respects CPT exactly, you inherit a strict accounting system. And that accounting system turns out to solve, with no new ingredients, one of the biggest open problems in all of science: the identity of dark matter.
Quick grounding, because the phrase gets thrown around loosely. When astronomers weigh galaxies by the motion of their stars, and weigh them again by the light their matter emits, the numbers disagree wildly. Roughly 85% of the matter in the universe is invisible, detectable only by its gravity. It does not shine, absorb, or scatter light. Planck, the European satellite that mapped the afterglow of the Big Bang between 2009 and 2013, measured the split with exquisite precision. About 5% of the cosmos is ordinary matter, about 27% is dark matter, and the remaining 2/3 is the still stranger dark energy. Dark matter outweighs everything you have ever seen 5-to-1, and after 90 years of searching, laboratory experiments have caught exactly none of it. The standard model of particle physics offers no candidate. But it does contain a famous gap, a missing puzzle piece so natural that its absence is itself a clue. Neutrinos, the ghostly particles that pour through your body by the trillion every second, come in 3 kinds, and every neutrino ever detected is, in the particle physicist language, left-handed, its spin winding one way around its motion. Every other particle of matter comes in both handednesses. The right-handed neutrino is the only slot in the Standard Models table that stands empty. For decades, theorists have suspected the slot is filled by a particle we cannot see, because a right-handed neutrino would feel none of the 3 Standard Model forces except gravity. It would be invisible by construction. Physicists call it the sterile neutrino, deaf, mute, and dark. Here is where the mirror does its work. In a CPT-symmetric universe-anti-universe pair, the mathematics selects a unique quantum state for every field, with no freedom to fiddle. Ask, in that state, how many of these sterile neutrinos the bang itself produces. Not through collisions, not through any force, but gravitationally, conjured out of the vacuum by the sheer expansion of space-time, the way a violent storm raises waves on a harbour. The calculation returns a definite abundance for a given mass. Demand that this abundance equal the dark matter Planck measured, and the mass is fixed. No dials. One number falls out. The number is 4.8 times 10 to the 8th giga-electron volts, 500 million times the mass of a proton. A single elementary particle, one quantum, heavy as a modest bacterium, 500 million hydrogen atoms compressed into a point with no size at all.
Nothing a collider has ever made comes within a factor of 10,000 of it. The Large Hadron Collider tops out around 10 to the 4th giga-electron-volts. If this theory is right, the dark matter that outweighs the visible universe 5 to 1 is a gas of these giants, forged by gravity in the first instant, streaming through the room you are sitting in right now. And the reason every underground detector on Earth has come up empty is simple. The particle touches nothing. It cannot scatter off your detector because it feels no force that could do the scattering. It is dark not because it hides, but because it is deaf. Turok described the production mechanism with a phrase worth keeping. The dark matter was radiated from the bang, he said, like Hawking radiation from a black hole. Never in thermal contact with anything, never in equilibrium, just the geometry of the beginning shedding particles as it stretched. The model makes a further neutrino prediction, and this one has a date attached. For the accounting to close, the 3 familiar light neutrinos cannot all have mass. Exactly one of them must be precisely massless. Not light, massless. Current experiments cannot yet tell whether the lightest neutrino has a tiny mass or none, but the next generation of galaxy surveys, Europe's Euclid Space Telescope, launched in 2023, and the Vera C. Rubin Observatory in Chile, will weigh the neutrino family against the growth of cosmic structure and can settle it. A confirmed massless neutrino would be a striking point for the mirror. A measured mass for the lightest neutrino would be a wound. Keep this number in mind too, the stability requirement. For the sterile giant to be the dark matter, it must survive 13.8 billion years, which the model arranges with a strict symmetry that forbids its decay, making it exactly stable. Hold that word, stable, in your pocket. In about half an hour, it will collide with a balloon over Antarctica, and the collision is one of the strangest episodes in recent physics. I know this stretch has been dense, so pause on something small. The next time you stand at a sink, look at the glass for 2 seconds. The claim on the table tonight is that the oldest question you can ask at that sink, what was here before everything, may have the same answer as the question of what stands behind your reflection, a second copy of the scene, written backward, demanded by symmetry. Whether it is a place or a proof, the universe on this side had no choice but to be smooth, and no choice but to be full of invisible giants. That is what a mirror at the beginning buys you. Now we need the rival. You cannot weigh a challenger without putting the champion on the scale, and the champion has held the belt for over 40 years. In the early 1980s, cosmology had a crisis of embarrassments. The universe was too uniform, regions on opposite sides of the sky, which in the standard picture had never been in contact, somehow sat at the same temperature, as if 2 strangers on different continents had independently written the same 1,000-word essay. The universe was also too flat. The geometry of space balances today on a knife edge between curving open and curving closed, and running the equations backward, that balance requires the initial conditions to have been tuned to dozens of decimal places. Alan Guth, then a young researcher, proposed in 1980 a radical fix, sharpened over the next 2 years by Andre Linde and by Andreas Albrecht working with Paul Steinhardt. Suppose the newborn universe went through a burst of expansion so violent it defies analogy, doubling in size dozens of times over in a sliver of a second. Any wrinkles would be stretched flat, the way inflating a balloon smooths its creases. Any temperature differences would be ironed out, because the entire observable universe would descend from a single tiny patch that had time to reach one temperature before the stretching began. The proposal is called cosmic inflation, and it did something more impressive than solving the embarrassments it was built for. It made a prediction nobody asked of it. Inflation is driven in the mathematics by a field, a kind of energy fog filling space, and quantum mechanics forbids any field from sitting perfectly still. The field must jitter. Inflation grabs those microscopic quantum jitters and stretches them to astronomical size, printing them across the sky as slight variations in density. Those variations become the seeds of galaxies. The theory predicts the statistical pattern of the seeds, almost the same strength at every scale, but not exactly, with a slight, calculable tilt favoring large scales, and the pattern should follow the bell curve statistics of pure randomness. When satellites finally read the pattern off the sky, first COBE in the 1990s, then WMAP, then Planck, the seeds were there, bell-curved, nearly scale invariant, tilted. The tilt has a name and a number, and both matter tonight. The name is the scalar spectral index, written n sub s. If the seeds were identical at every scale, ns would equal exactly 1. Planck's final analysis measured ns equals 0.9649, plus or minus 0.0042, 8 standard deviations below 1. The tilt is real, the fingerprint is genuine, and any theory of the beginning must now reproduce that number or die. Keep 0.9649 in mind. Two theories are about to fight over it. Inflation's version of the number comes from its second equation of the night, and this one is worth speaking aloud. In slow roll inflation, ns equals 1 minus 6 epsilon plus 2 eta. Epsilon and eta are the slow roll parameters. Epsilon measures the slope of the inflating field's energy hill, how steeply the fog's energy falls as the field rolls, and eta measures the curvature of that hill, whether the slope is easing or steepening. Picture a marble rolling down the inside of an enormous, nearly flat salad bowl. Epsilon is how tilted the bowl is under the marble right now. Eta is whether the bowl is flattening out or dropping away ahead. The marble's exact path down the bowl decides the tilt printed on the sky. And that is both inflation's glory and its wound. The prediction depends on the shape of a bowl nobody has ever seen, a potential energy curve chosen by the theorist. Choose one bowl, get one tilt. Choose another, get another. The wound has a second, deeper cut. Because inflation stretches quantum jitters in everything, it should also have stretched jitters in space-time itself, printing a background of primordial gravitational waves across the cosmos. Long wavelength ripples in geometry surviving to this day. Their strength is measured by a number called R, the tensor-to-scalar ratio, the loudness of the space-time ripples compared to the density seeds. Simple, natural versions of inflation predict R large enough to detect. And for a decade, some of the most sensitive instruments ever built, the BICEP and Keck telescopes at the South Pole, staring at the polarization of the cosmic microwave background through the driest air on Earth, have hunted that signal. The current verdict, combining BICEP Keck with Planck, R is less than 0.036, not detected. The upper limit keeps falling, and each fall quietly deletes another family of inflationary models. In 2014, the BICEP team famously announced the detection. Champagne was opened, and within months the signal dissolved into polarized dust in our own galaxy, one of the most public retractions in modern science. The primordial waves have never resurfaced. Now place the CPT-symmetric universe next to that. What does the mirror model predict for R? 0. Exactly 0. No inflating field, no stretch spacetime jitters, no primordial long-wavelength gravitational waves at all. The universe emerges radiation-dominated from the mirror, and the mechanism that would print tensor ripples simply is not there. This is what a falsifiable theory looks like. One clean number, no adjustment possible. If any experiment ever detects primordial B-mode polarization, the curling fingerprint those waves would leave on the microwave sky, the CPT-symmetric universe is dead on the spot, and Turok has said so plainly. Inflation, by contrast, can retune its bowl and survive almost any R. One theory bets its life on 0, the other cannot lose. Which of those postures should earn a scientist's respect? Hold the question. It is the hinge of this entire video, and we will return to it with the scales out. And the tilt? In 2023, Turok and Boyle pushed the mirror model further and derived their own NS. The derivation is the strangest calculation in this story. The tilt comes out tied to the strength of the strong nuclear force, evaluated at the highest energies, through a formula with no adjustable pieces. Spoken plainly, NS approximately equals 1-7 times the strong coupling at the Planck energy divided by pi. The number it returns is 0.958. Planck measured 0.9649 plus or minus 0.0042. Close. Provocatively close, within about a standard deviation and a half of the real sky, from the physics of quarks with no bowl to sculpt. But the same 2023 calculation also returns the overall strength of the seeds, and there it strains. The predicted amplitude comes out around 12.9 plus or minus 4.5 in the natural units, where Planck measures 21.0 plus or minus 0.3, about 2 standard deviations low. The authors printed the tension themselves and wrote on the record that the result rests on assumptions they have yet to verify, and that much remains to be understood. Keep that admission. When we weigh the theories, candor will count as evidence. What does it mean that a theory of the universe's first instant can be graded to the third decimal place against the sky? Whatever else is true tonight, sit with the fact that this is possible at all. 2 rival stories about a moment 13.8 billion years gone, separated by numbers a satellite can read. This is not philosophy, it is bookkeeping with telescopes. And since the whole case now runs through those telescopes, you should know the 2 instruments whose numbers rule this video, because their stories are as remarkable as the theories they judge. Planck was a European Space Agency satellite launched in 2009 to a gravitational parking spot 1.5 million kilometers from Earth, where it spent 4 years staring at the oldest light in existence. That light, the cosmic microwave background, is the afterglow of the hot beginning itself, released when the universe was 380,000 years old and traveling ever since. Every cubic centimeter of the room around you holds hundreds of those original photons, arriving from every direction after a 13 billion year flight. Planck mapped their temperature across the whole sky to a precision of millionths of a degree, and out of that map fell the modern numbers of cosmology, the age of the universe, 13.797 billion years, give or take 23 million, 0.1%. The census of 5% ordinary matter against 27% dark, and the tilt, NS equals 0.9649, plus or minus 0.0042. 0.1% error bar on the age of everything. Hold your thumb and forefinger a hair apart. On the scale of all time, that is the width of our remaining uncertainty. When this video says the sky grades the theories, Planck is the grader's pen. The other instrument sits on the ground at the geographic South Pole, where the BICEP and Keck telescopes stare upward through the driest, stillest air on the planet, air so cold it cannot hold the water vapor that blurs microwave observations everywhere else. Their target is not the temperature of the ancient light, but its polarization, the subtle preferred orientation of its vibrations, because primordial gravitational waves, if they exist, would have twisted that polarization into a distinctive curling pattern called B-modes, a fingerprint nothing else in the early universe can forge. Planck saw half the sky coarsely. BICEP watches a chosen 1% of it obsessively, deep enough to notice a twist 100 times fainter than the temperature ripples. It was BICEP that raised the false alarm of 2014, and BICEP Keck that ground the limit down to R less than 0.036. The pattern they hunt is inflation's last unclaimed prediction and the mirror's standing death sentence. Somewhere on the polar plateau, right now, in 6 months of unbroken night, the referee of this entire video is collecting photons. Do you notice what has quietly happened across this section? The question of what lies beyond the beginning of time, the kind of question that once belonged to campfires, has become an instrumentation problem, with error bars, funding cycles, and a schedule. That migration from the unaskable to the measurable is the single most underrated achievement of modern cosmology, and both theories on trial tonight deserve credit for forcing it. Before the balloon, two more rivals deserve their moment, because the mirror is not the first attempt to tame the beginning, and the contrasts are where its character shows. In 1983, James Hartle and Stephen Hawking proposed the no-boundary wave function, the most poetic mathematics of its era. Their move, near the beginning, time itself loses its distinct character and becomes, mathematically, another direction of space. The universe then has no initial edge for the same reason the surface of the Earth has no edge at the South Pole. Walk south and south simply runs out, smoothly, without a wall. In the no-boundary picture, asking what came before the bang is asking what is south of the South Pole. The question dissolves. Notice the philosophical strategy. Hartle and Hawking eliminate the before by rounding the beginning off. The CPT model does the opposite. It keeps the bang as a genuine, pointed event, singular and Lorentzian, real-time all the way down, and instead of rounding it off, passes through it. One theory removes the mirror frame, the other polishes it. Both are answers to the same discomfort, that the naked singularity of the textbook picture explains nothing about the tidy universe that emerged from it. The second rival comes from Roger Penrose, the Nobel laureate whose theorems proved singularities are unavoidable in classical gravity in the first place. Penrose observed something profound about the beginning. It was not just smooth, it was thermodynamically pristine, an initial state of almost impossibly low gravitational disorder. And the entire arrow of time, every ticking clock and every cooling coffee cup, including yours, runs off that initial neatness like a watch running off its spring. His Weyl curvature hypothesis, proposed decades ago, decrees that the mathematical quantity measuring gravity's disorder, the Weyl tensor, must vanish at any initial singularity. His later conformal cyclic cosmology goes further, gluing the cold, far future of one universe to the hot birth of the next in an endless chain of eons. The parallels to the mirror model are obvious, and Boyle and Turok acknowledge them directly, noting the significant overlap with Penrose's hypothesis. But there is a decisive difference of principle, and it was Hawking, years earlier, who put his finger on it. The Weyl curvature hypothesis, he objected, is imposed by hand, an axiom bolted on, and worse, it is not CPT-symmetric. It treats initial singularities differently from final ones by fiat, and a Weyl tensor of exactly zero would conflict with quantum uncertainty besides. The mirror model's answer to both objections is its central boast. Nothing is imposed by hand. The smoothness is not decreed. It is derived, forced by the CPT symmetry of the pair, with the quantum jitters riding on top exactly as uncertainty demands. Where Penrose writes the tidiness of the beginning into the constitution, Boyle and Turok claim to prove it as a theorem. Are you keeping score? 4 theories of the beginning now stand in the room. The textbook singularity, time starts, no explanation offered. Inflation, an era of violent stretching launders whatever came before into smoothness. No boundary, the beginning is rounded off, the question dissolved. And the mirror, the beginning is a two-sided reflection, its tidiness a theorem, its dark matter a prediction, its gravitational wave silence a wager. There is a 5th position too, the one Turok himself abandoned. For years with Paul Steinhardt, he championed a cyclic universe of colliding membranes, bang after bang without a true beginning. He walked away from his own theory when he judged it needed too many unprovable moving parts. Whatever else you make of him, that is not the behavior of a man defending turf. It is the behavior of a man hunting for the theory that needs the least.
That word, least, is the soul of this whole program, so give it one breath of a bridge. Every profession has a version of this instinct. An accountant who needs 17 special adjustments to make the books balance starts to suspect the books.
a mechanic who needs 5 custom parts to explain one rattle starts to suspect the diagnosis. Turok's stated complaint about modern cosmology, delivered in public with the bluntness of a man with tenure and nothing to prove, is that its reigning models have accumulated adjustable parts. Their reliance on ad hoc parameters makes them, in his words, increasingly resemble Ptolemy's description of the solar system, the beautiful, wrong machinery of epicycles that fit the data perfectly for 14 centuries while being false in every gear. The mirror universe is his and Boyle's attempt at the opposite, a cosmology of almost insolent economy. The particles already known, the gravity already written, one symmetry already proven. And everything else, the smoothness, the flatness, the dark matter, the tilt, falling out as consequences. Whether nature agrees is a different question, and the scales come out soon. But you should understand the wager's shape. This is a bet that the universe is simple at the exact place every other theory assumes it is complicated. Now the balloon. Between December 2006 and January 2007, a NASA payload the size of a small building drifted on the polar wind 37 kilometers, about 23 miles, above Antarctica, hanging from a helium balloon. Its name was ANITA, the Antarctic Impulsive Transient Antenna, and its job was eavesdropping. An array of radio horns pointed down at 3 million square kilometers of ice, listening for the faint radio crackle produced when an ultra-high energy particle from space slams into the atmosphere or the ice sheet. The physics of that crackle is well understood. Cosmic rays scream in from above, shatter against the atmosphere, and their radio signature reflects off the ice up to the antennas with a characteristic inverted polarity, the way a face reflected in a spoon flips. Everything about the geometry is diagnostic. ANITA knows which way a signal came from. On one flight, and again on the 2014 flight of its successor ANITA 3, the instrument recorded something with no place in that tidy geometry. An enormous radio pulse rising out of the ice from below, steeply, at angles of 27 and 35 degrees below the horizon, with polarity not inverted, meaning no reflection. Whatever made those two pulses looked for all the world like a particle shower bursting upward out of the Earth, as if something had flown through the planet and erupted from the ice like a submarine-launched missile. The reconstructed energies sat around 0.6 exa-electron volts each, 6 times 10 to the 17th electron volts, hundreds of thousands of times beyond the Large Hadron Collider, packed into single particles. Could a known particle do that? Ask the question precisely, because the precision is the story. Of all known particles, only a neutrino could pass through the Earth at all. Everything else is absorbed within kilometers of rock. But neutrino absorption rises steeply with energy, and at 0.6 exa-electron volts, the Earth is opaque even to neutrinos along those steep trajectories. A team led by Derek Fox at Penn State ran the numbers and published the verdict. The probability of any standard model particle surviving that passage is below 1 in a million. The events, taken at face value, are inconsistent with all of known physics at 5.8 standard deviations. In particle physics, 5 standard deviations is the discovery threshold. The ANITA anomalies cleared it with room to spare. Within months of the Mirror Universe papers, a group led by Luis Anchordoki at Lehman College in New York connected the two headlines of that season. Recall the number you have been carrying: 4.8 times 10 to the 8th giga-electron volts, the predicted mass of the sterile neutrino dark matter. Write it in different units and it is 480 peta-electron volts, which is, within errors, the energy scale of the ANITA events. Anchordoki's proposal? A dark matter particle of exactly the Boyle-Finn-Turok mass, gravitationally accumulated inside the Earth, decays. The decay fires a Higgs boson and a light neutrino. The neutrino plows upward through thousands of kilometers of rock, and near the surface converts into a tau lepton that bursts out of the ice as an upgoing shower. The title of their paper said it outright: upgoing ANITA events as evidence of the CPT-symmetric universe. For one giddy moment, it looked as if a balloon over the ice had caught the mirror universe's fingerprint falling out of the ground. Turok's reaction is the most instructive sentence in this whole affair, so hear it in full. It is possible to make these particles decay over the age of the universe, he said, but that takes a little adjustment of our model. So we are still intrigued, but I certainly would not say we are convinced at this stage. Catch what he is doing there. His own theory requires the dark particle to be exactly stable. That is what keeps it around to be dark matter. The ANITA interpretation requires it to decay. That is what makes the upgoing shower. You cannot have both without loosening the very economy that makes the model beautiful. Offered the most sensational possible confirmation of his own idea on the front pages, Turok flagged the fly in the ointment himself. Scientists talk constantly about killing your darlings. It is rarer to watch one decline to adopt a darling that came begging. His caution has aged well. The follow-up record, and this channel reports follow-up records, runs one way. A reanalysis by Andrew Romero Wolf and collaborators disfavored a diffuse flux of tau neutrinos as the origin. IceCube, the cubic kilometer neutrino observatory frozen into the ice at the South Pole, searched its vastly larger exposure for anything similar and found nothing. And in 2025, the Pierre Auger Observatory in Argentina, the largest cosmic ray detector on Earth, published a dedicated hunt for upward-going showers, one candidate against an expected background of 0.27, exactly what noise predicts. Meanwhile, sober explanations surfaced for the original events. Radio pulses from showers reflecting off buried ice layers, or transition radiation as a shower crosses the ice surface, either of which could mimic the uninverted polarity without any particle passing through the Earth. The community's center of gravity today leans mundane, a glaciological illusion, not a message from behind the mirror. The successor instrument, PUEO, flies with sharper eyes to settle it. That is where the balloon story honestly stands, an anomaly that cleared discovery significance, a proposed link to the anti-universe made by serious people in the peer-reviewed literature, a null chorus from every larger detector since, and a theorist who refused to claim his own trophy. Science working exactly as advertised. What does it mean that the most spectacular potential evidence for the mirror was set aside by the mirror's own author? File that under character witness. Now file the harder question next to it. With the balloon set aside, what evidence does carry the model? The answer runs through the one problem that nearly killed the theory in peer review, and the fix that either completes it or breaks it, depending on which cosmologist you ask. When Boyle, Finn, and Turok submitted the mirror papers, the referees pressed on the sky's most important feature, the seeds. Planck's map of the microwave background is speckled with those 1 in 100,000 density ripples, and inflation's whole claim to the throne is that it explains them, quantum jitters stretched to cosmic size with the measured tilt. The 2018 mirror model, for all its economy, had no story for the ripples at all. A smooth universe with nothing written on it. Turok told the story of the refereeing himself, with characteristic bluntness. They said you have to explain the fluctuations, and we said that is a work in progress. Eventually they gave in. The papers were published with the gap on display. Pause on that admission, because it is load-bearing in both directions. A theory that publishes with a known hole, saying work in progress out loud, is being honest. It is also incomplete, and incomplete next to a rival that nails the ripples is losing. For 5 years, that was the scoreboard. The 2023 attempt to fill the hole is the strangest and most contested piece of this entire structure. Turok and Boyle argued that making gravity's quantum bookkeeping consistent on the mirror geometry, cancelling a set of mathematical defects called anomalies that would otherwise poison the theory, demands the existence of 36 additional fields of an exotic type called dimension zero scalars. Not 35, not 40, 36, forced by arithmetic. These fields do something no ordinary matter does. They carry fluctuations without carrying energy density, ghosts in the machinery whose only job is to print statistical ripples onto the geometry. From them, as you heard, the pair derived the tilt, 0.958 against Planck's 0.9649, and the amplitude, 12.9 against the sky's 21, the 2 sigma strain they printed themselves, alongside the caveat that key assumptions remain unverified. If the derivation survives scrutiny, it is astonishing. The texture of the entire cosmic web, every cluster and void, computed from the strong nuclear force and a symmetry with no inflaton bowl anywhere. If it does not survive, the mirror goes back to being a beautiful, smooth universe with nothing written on it. That is the open wound where this theory lives or dies, and honest coverage says so. There is a second 2018 era gap the team has since attacked with more success: why the universe is flat. Here the 2024 work of Turok and Boyle turns to the oldest bookkeeping in physics, entropy, the count of ways a system can be arranged. Their third equation of the night, spoken plainly, the gravitational entropy of a cosmology scales as the fourth root of the de Sitter entropy times the radiation entropy. Unpack the words. De Sitter entropy is the disorder budget associated with the universe's accelerating expansion, an enormous number set by dark energy. Radiation entropy is the photon count, in effect. The formula weighs how many ways a universe can exist for each possible spatial curvature, and the count is overwhelmingly dominated by universes that are flat, homogeneous, and isotropic. Think of a casino's ledger. You do not need to predict any individual hand to know the house wins the year. You count the ways. In this accounting, a flat, smooth universe is not an absurdly balanced accident demanding explanation. It is the house outcome, the geometry with almost all the tickets. Where inflation flattens the universe with machinery, the mirror model claims flatness was always the overwhelmingly most probable book entry. And the matter itself, the fact that anything is here at all? Every antimatter factory on Earth confirms that particles and antiparticles are born in pairs and die in pairs. Run the early universe forward from pure radiation, and you should end with pure light, every particle annihilated against its twin. Yet here you sit, made of leftover matter, roughly 1 part in a billion of the original census that somehow lacked a partner. The benchmark number, the baryon to photon ratio, our fourth and final equation, E to B equals the number of baryons minus antibaryons divided by the number of photons, approximately 6 times 10 to the minus 10. 6 survivors worth of imbalance for every 10 billion photons of annihilation light. Picture a stadium of 10 billion seats where every person came paired with a double, all destined to cancel out at the exit, except 6 people whose doubles never showed. Everything you have ever touched is built from those 6. The mirror model's account is leptogenesis, the standard mechanism cosmologists already favored. The 2 heavier right-handed neutrinos, the unstable siblings of the dark matter giant, decay in the early universe with a slight preference for matter, and known processes called sphalerons convert that preference into the baryon excess. Nothing new is invented, but the mirror adds one elegant line to the ledger. Whatever matter excess forms on our side forms as an antimatter excess on the far side. Count the pair together and the books balance to 0, perfectly, globally. The universe did not break the matter-antimatter symmetry. It kept the symmetry, and we are living in one half of the balance sheet. I have been piling stone on stone for a while now, so set the load down for a breath. All of this, the mirror, the giant particle, the flat house odds, the balanced books, radiates from one idea you can hold while brushing your teeth. The reflection completes the symmetry. You alone are lopsided. You plus the glass are balanced. If that one idea is right about the cosmos, then the strangest features of your sky, the invisible weight in the galaxies and the impossible tidiness of the beginning, stop being mysteries and start being consequences. Mysteries demand machinery. Consequences only demand honesty about what the symmetry already says. That trade, machinery for honesty, is the entire proposition on the table tonight, and you now hold every piece of it that matters. Two more voices belong in the record before the weighing, one critic and one referee of a different kind. The critic is Grigory Volovich, a distinguished theorist who examined the mirror construction and argued that the analytic continuation, read physically, implies the far side behaves like a system at negative temperature, hotter than infinity in the thermodynamic bookkeeping, and that the bang is better understood as a bifurcation point than a smooth pass-through. Whether that reading is fatal, decorative, or secretly equivalent is still being argued in the literature, and you should know the argument exists. The referee is the sky itself, through a prediction almost nobody talks about. In 2024, Wei-Ning Deng and Will Handley at Cambridge worked out the mirror universe's finite size implications and found it does not permit just any spatial curvature. It permits a discrete menu, specific values, the largest being a curvature parameter near -0.016, then -0.011, then -0.004, and so on. Quantized geometry on the largest possible scale. Planck's current measurement brackets 0 with just enough slack that the first entries of the menu survive. Future surveys will shrink the bracket. If the measured curvature ever lands cleanly on the menu, it would be the eeriest confirmation in the history of cosmology. If it lands off the menu, another wound. Almost no other theory of the beginning is reckless enough to publish a menu at all. Let us go deeper into the machinery, because three pieces of it deserve more than a mention, and each one carries a question you are probably already asking. First, how exactly does an expanding universe conjure particles out of nothing by gravity alone? The phrase gravitational particle production sounds like an incantation, but the physics is concrete, and it was worked out decades before anyone needed it for dark matter. In quantum field theory, what we call empty space, the vacuum, is not empty. It is defined as the state of lowest energy, and that definition depends on the geometry of space-time. Here is the decisive subtlety. The lowest energy state of a static universe and the lowest energy state of an expanding universe are not the same state. Space that stretches redefines what emptiness means. So take a region that is a perfect vacuum by the old geometry, stretch it violently, and measure it by the new geometry. It is no longer empty. It contains particles. Nothing snuck in. The stretching itself resorted the quantum ledger, and states that used to count as nothing now count as something. Picture a harbour at dead calm, glass flat, the definition of stillness. Now let the seabed itself heave upward in a storm. When the heaving stops, the water is churning with waves, though not one drop was added. The waves are the seabed's motion, translated into the water's language. The expansion of the universe near the bang is the heaving seabed. The sterile neutrinos are the waves. And the beauty of the CPT calculation is that the mirror symmetry fixes the vacuum uniquely, no choices allowed, so the number of waves is not adjustable. It is an output, enough sterile neutrinos at 4.8 times 10 to the 8th giga-electron-volts, to be all the dark matter Planck weighed. On the ordinary matter side of the ledger, this mechanism produces almost nothing. The giant is the only particle heavy enough and aloof enough to be born this way in quantity. The theory does not merely allow dark matter, it cannot avoid it. Could we ever catch one? Not by collision. The particle ignores every force that builds detectors. But there is a back door: decay. If the sterile giant is not perfectly stable after all, if the protecting symmetry is even slightly imperfect,
Then, once in a very great while, somewhere in the galaxy's dark halo, one of them dies, and its death would spray particles of nearly 500 million proton masses worth of energy into the void. Researchers led by Marco Duran and Stefano Profumo calculated the reach of our instruments. The giant Cherenkov telescope arrays could sense such decays for lifetimes up to about 10 to the 27th seconds, and IceCube pushes toward 10 to the 30th. Absorb those numbers. The universe is about 4 times 10 to the 17th seconds old. We can test the mortality of a particle on timescales 1 trillion times longer than the age of everything. The searches so far see nothing, which is exactly what the strict mirror model demands. Its dark matter is forever, and every null result is, in a strange inversion, a small vote in its favor, even as it slams the door on the ANITA romance. Second, the vacuum itself. Because I glided past the most radical sentence in the 2018 papers. In quantum field theory on a curved, time-dependent spacetime, there are infinitely many candidate definitions of the vacuum, and choosing one is normally a headache verging on a scandal. Different choices give different particle contents, different predictions, different universes on paper. Every cosmological calculation you have ever heard of makes such a choice somewhere, usually with a plausibility argument standing where a principle should be. The mirror construction is the exception. Demand that the state of the universe-anti-universe pair be invariant under CPT, and the infinite menu collapses to a single entry. One vacuum, no discretion. The theory's deepest boast is not the anti-universe and not the dark matter. It is that the beginning of the cosmos stops being a free parameter. What does it mean that the most arbitrary-seeming feature of reality, its opening state, might be the one thing symmetry refuses to leave open? Turn the question over. Every rival account must, at some point, reach in and set the initial conditions by hand, the way a stagehand places props before the curtain. The mirror model claims the script places its own props, that a universe obeying CPT has exactly one way to raise the curtain. If that claim survives, cosmology changes kind, from a historical science, reconstructing contingent events, to something closer to geometry, deriving necessities. Third, the strangest bonus prediction, the one even physicists double take at. In 2022, Boyle and Turok, with Martin Teuscher, applied the mirror to a 40-year-old puzzle from a completely different corner of physics, called the strong CP problem. In brief, the equations of the strong nuclear force contain a dial, an angle, that could sit anywhere on its circle, and almost any setting would give the neutron a measurable electric lopsidedness, an electric dipole moment. Experiments hunting that lopsidedness with heroic precision find nothing. The dial sits at 0 to better than 1 part in 10 billion. Why? The standard answer invents a new field, the axion, with its own particle and its own industry of detectors searching for it. The mirror's answer, in the 2022 paper titled The Big Bang as a Mirror, a solution of the strong CP problem, is that the reflection itself forbids the dial from turning. The CPT boundary condition at the bang forces the angle to 0, with no axion and no new particle at all. Another one-line entry in the ledger of things the mirror gets for free. The pattern by now is unmistakable, and it is the pattern that makes this theory feel different in the hand from its rivals. It keeps solving problems it was not built to solve, which is either the signature of a deep truth or the most elaborate coincidence in theoretical physics. It is worth pausing to notice that the idea has an ancestor, because good ideas usually do. In 1967, the Soviet physicist Andrei Sakharov, the same Sakharov who built thermonuclear weapons and then became his country's most famous dissident, published the founding paper of baryogenesis, the study of why matter outnumbers antimatter. In that same short paper, almost as an aside, he floated a vision, a universe symmetric about the moment of the bang,
with the arrow of time pointing away from it in both directions, and antimatter dominating the other branch. The tools to make the vision precise did not exist in 1967. It sat in the literature for half a century, a sketch waiting for its mathematics, until conformal symmetry, analytic continuation, and the modern machinery of quantum fields on curved spacetime turned the sketch into the two-sheeted cosmos we have spent this hour inside. Science keeps such promissory notes for a long time, and sometimes it pays them.
There is one more debt the mirror claims to pay, and it may be the deepest of all: the direction of time itself. Stop and feel the problem first, because familiarity hides it. Every fundamental law of physics works equally well forward and backward. Run any particle collision in reverse, and it is an equally legal collision. Nothing in the microscopic rulebook distinguishes past from future. Yet your coffee only cools, your cups only shatter, you only remember one direction. Where does the one-way street come from if the map has no arrows printed on it? The standard answer pushes the mystery to the wall. The universe began in an extraordinarily ordered state. Disorder has been growing ever since, and the growth of disorder is the arrow. True, but it trades one mystery for another, because now you must explain why the beginning was so exquisitely ordered, and the textbook picture simply shrugs. Initial conditions. In their 2021 paper on the two-sheeted universe and the arrow of time, Boyle and Turok offer the mirror's answer. The bang is the point of perfect reflection, the state of highest symmetry and lowest gravitational disorder, not by assumption, but by the CPT clamp. The two arrows of time are simply the two directions leading away from it, each side's disorder growing as it recedes from the mirror. Time does not flow one way in this picture. It flows both ways, away from the middle, and every observer on either sheet rides their own outbound arrow and calls it the future. What does it mean that the direction of your life, the most intimate fact of your existence, might be one half of a symmetry, balanced by an equal and opposite flow on the far side of the beginning? The mirror does not merely add a universe, it proposes an origin for the difference between yesterday and tomorrow. The proposal does not resolve every puzzle of time's arrow, and the Volovic critique you will meet shortly bites exactly here. But register what has happened. A question usually parked in philosophy departments has been turned into a boundary condition calculation with referees. That is this theory's signature move, performed on the hardest target there is. And what about the program's vitality now? A theory's health shows in whether it keeps generating work. Boyle's 2024 paper explores what he calls black mirrors, CPT-symmetric alternatives to black hole interiors, pushing the reflection trick from the beginning of time into the hearts of collapsed stars. The Cambridge group of Will Handley keeps grinding the model against data, quantized curvature, primordial power spectra, the future conformal boundary. Follow-up papers propose sharpened derivations of the perturbations. Critics like Volovic keep publishing objections. The 2025 paper on fixed points of classical gravity extends the framework again. You do not have to believe a word of the mirror to recognize the sociology. This is a living research program, refereed, contested, and productive, not a press release that came and went. So let me assemble the full picture the mirror paints in one continuous pass, because scattered pieces do not do it justice, and because you have now earned every term in it. In the beginning, there is no beginning. There is a boundary, a moment of perfect reflection. On either side of it, a universe expands, filled first with radiation, hot and smooth, its smoothness enforced by the symmetry of the boundary the way a clamped string's tone is enforced by the clamp. The two sheets are images of each other under the one transformation the laws of physics hold exactly. Matter for antimatter, left for right,
forward for backward. Gravity, stretching the newborn geometry, breeds a precise population of invisible giants into each side, 500 million proton masses apiece, deaf to every force but weight. And they remain today as the dark scaffolding inside every galaxy, including the one holding you. The heavier siblings of those giants die young, tilting the census of matter by 6 parts in 10 billion. And the tilt on our side is the anti-tilt of theirs, so the grand total remains exactly balanced. Space is flat because flatness holds nearly all the tickets in the entropic lottery. The texture of the galaxies is, if the contested 2023 derivation holds, the strong nuclear force's handwriting. No space-time ripples from the first instant, none, ever, at any wavelength. And the whole structure stands on one foundation, that the universe, taken in full, is as symmetric as its laws. Against that, hold up the reigning picture with equal fairness. In the beginning, something we do not know. Then a burst of inflation driven by a field we have not identified, rolling down an energy landscape we cannot derive, which stretched the cosmos flat, ironed it smooth, and printed quantum jitters across it as the seeds of galaxies, with a tilt the data confirms. The field decayed into the hot soup of particles by a mechanism that can be modeled many ways. Dark matter is some particle outside the standard model, identity unknown, produced by one of several possible mechanisms. The matter excess arose from one of several possible baryogenesis channels. Space-time ripples from inflation exist at some amplitude, possibly just below every limit so far. Each unknown has candidate answers. None is forced. Inflation is a framework of extraordinary success and extraordinary flexibility. And its flexibility is precisely what its critics, Turok loudest among them, hold against it. Do you see now why this is not a crank story? Two coherent, mathematically serious pictures of the beginning sit on the table. One is established, flexible, and hungry for parameters. One is young, rigid, and starving by choice. The sky has begun grading both. It is time to read the grades. Before the reading, one more breath, because the next stretch is the destination and I want you fresh for it. Somewhere today you passed a window at night or a dark phone screen and saw the room behind you doubled. You did not mistake the doubled room for a second apartment. But notice, the reflection obeyed every law the room obeyed. Symmetry is not decoration, it is constraint. Every reflection is a small proof that the laws work the same both ways. The question this video turns on is whether the entire cosmos, at its first moment, is bound by that same constraint, and the answer is being measured at the South Pole and in orbit, in polarized microwaves, in neutrino masses, and in the curvature of space right now while you watch this. A handful of objections have probably been collecting in your mind through all of this, and they deserve direct answers before any verdict, because they are the right objections. Is this just the multiverse again, wearing a new coat? No, and the difference is structural. Multiverse proposals multiply, endless bubble universes, endless variations, mostly unobservable in principle and unconstrained in number. The mirror is one reflection, demanded by one symmetry, with its properties locked to ours by that symmetry, and it buys its keep in testable predictions on our side. A hall of mirrors and a single pane of glass are not the same architecture. Whatever you think of the multiverse, this is a different, far more disciplined object. Is a universe made of antimatter even stable? Would it not annihilate? Only contact annihilates, and the sheets touch nowhere except the sealed boundary at the bang. On its own side, antimatter is as stable as matter. An antihydrogen atom, which laboratories at CERN routinely trap and study, sits as calmly as hydrogen. The far sheet's chemistry, stars and galaxies, would run identically to ours, mirrored in charge, with no way to meet our matter and burn. If time runs backward over there, Does cause still precede effect? On their side, yes, entirely. Their causes precede their effects along their arrow. The backward description exists only in our coordinates, and coordinates are labels, not physics. Nothing over there ever violates its own causality, just as nothing in your mirror moves before you do from the mirror's own point of view. Why should the universe obey a theorem proved for particle physics? The honest answer: it must, if the universe is described by a relativistic quantum field theory, which every scrap of evidence says it is, up to the unknown territory of quantum gravity. And that caveat is genuine. At the singular point itself, quantum gravity rules, the theorem's fine print is untested, and Boyle and Turok's construction sidesteps rather than solves that regime, reasoning about the fields without ever standing on the singular point, by their own description. If quantum gravity refuses to cooperate, the mirror cracks. Every theory of the beginning currently alive carries an equivalent unpaid debt, and none of them advertises it. This one at least itemizes it. For most of this video, I have laid the two pictures side by side without judging them. That neutrality was deliberate, and it ends now. The evidence is on the table. The job of this final stretch is to weigh it, category by category, the way a referee would, and to say plainly where each theory stands, where each one bleeds, and what would settle the fight. And as we start the weighing, plant one last question in your pocket, because it is the question the entire evening has been circling, and only the very end of this video will answer it. Does the anti-universe actually have to exist, as a place, for any of this to be true? Hold it. We will come back to it last. Begin with the universe's smoothness and flatness, the original embarrassments. Does inflation explain them? Yes, genuinely. A stretch of accelerated expansion irons both, and this is the achievement that won inflation the throne. Does the mirror explain them? Also yes, and by very different means. The smoothness is forced by the CPT boundary condition, the clamp on the string, and the flatness is the overwhelmingly most probable geometry in the entropic count of Turok and Boyle's 2024 ledger. Score the category even, with a footnote worth its weight. Inflation achieves the smoothing with machinery added to physics, and the mirror achieves it with a constraint already in physics. If you believe explanations should be priced by the assumptions they consume, the footnote leans mirror. If you believe track record prices higher than parsimony, it leans inflation. Both accounts work. Neither is free of philosophy. That is an honest tie. The tilt of the seeds, NS equals 0.9649, who owns that number? Inflation predicted a red tilt in advance, decades before Planck pinned it, and that genuine forward prediction is inflation's finest hour. But the specific value floats with the model chosen, bowl by bowl. The mirror's 2023 derivation returns 0.958 with nothing to tune, remarkably near the mark, but it arrived after the measurement, and it leans on those 36 ghost fields and on assumptions the authors themselves flag as unverified. So grade it honestly from both directions. Inflation predicted the sign and can fit the value. The mirror derived a value, close but late and resting on contested scaffolding. Advantage inflation, narrowly, with the mirror's attempt registered as the boldest single calculation in the file. The amplitude of the seeds, the loudness of the cosmic texture. Planck hears 21 in the natural units. Inflation can produce any loudness at all, which means it fits the data and explains nothing about the specific number. A dial is not a derivation. The mirror computes 12.9 plus or minus 4.5, a real number from real physics, sitting about 2 standard deviations under the sky. What does it mean that a theory can be 2 sigma from glory with no dial to turn? It means exactly what it says. The calculation is either wrong somewhere subtle or unfinished, or the universe is telling us the mirror's texture mechanism is not the whole story. 2 sigma is not a death sentence. Measurements and derivations both drift as they mature. But tonight, on this category, the honest card reads, inflation fits by construction, the mirror strains on the record. Advantage inflation, again narrowly, and again with an asterisk that only one contestant showed its arithmetic. The primordial gravitational waves. Here the whole tournament may someday be decided in an afternoon. Inflation's simplest and most natural versions wanted R large enough to see, and the sky has said no and no and no again, down through R less than 0.036, with the 2014 false alarm as a cautionary monument. Inflation survives by retreating to quieter models, as it always can. The mirror does not retreat because it cannot. R equals 0 forever, on pain of death. Every year the limit falls without a detection is a year the rigid theory outlives its own execution date, while the flexible theory rewrites its will. Score the category this way. The data so far is exactly what the mirror demands and merely what inflation permits. That is not proof. Absence never is. But in the court of scientific method, a survived execution attempt outranks an alibi that can be rewritten, and this category, as of tonight, leans mirror. Dark matter. Inflation, as a theory of the early universe's expansion, simply does not speak to dark matter's identity. Its allied frameworks offer a crowded field of candidates, decades of direct searches, and so far, empty hands. The mirror puts one name and one number on the table: a sterile neutrino, 4.8 times 10 to the 8th giga-electron-volts, stable, invisible by construction, produced gravitationally in an amount that matches the Planck census with no freedom. Unverifiable by collision, yes, and that is a real epistemic cost. A particle that cannot scatter is a particle that cannot be caught in a tank under a mountain. But it is testable at the edges, through the massless neutrino requirement that Euclid and Rubin will probe, through decay searches that keep coming back empty exactly as strict stability demands. A named, numbered, falsifiable candidate against a field of possibilities. On specificity alone, advantage mirror. The matter excess. Both pictures lean on leptogenesis, so the mechanism itself is shared ground. The difference is what the excess means. In the standard picture, the universe globally violates the matter-antimatter balance, and CPT applied to the whole cosmos simply fails as a description of the state. In the mirror, the balance is exact and global, 6 parts in 10 billion here, minus 6 parts in 10 billion there, and the deepest symmetry of physics keeps its perfect record at the largest possible scale. No measurement we can perform from inside one sheet distinguishes the two accountings, so no points can be awarded on evidence. But note, for the record, which picture asks less. One asks you to accept that the universe's state breaks the one symmetry its laws never break. The other asks you to accept a second sheet. Every viewer can weigh those costs for themselves, and reasonable people land differently. That is not evasion, that is the actual state of play. Falsifiability, the category Karl Popper would have chaired. List the mirror's exposed organs. A B-mode detection kills it. A measured mass for the lightest neutrino wounds it gravely. A curvature measurement off the discrete menu wounds it. A confirmed decay of galactic dark matter at the wrong lifetime contradicts its stability requirement. 4 named ways to die, all within reach of instruments now operating or under construction. Now list inflations. No single observation on anyone's horizon can falsify inflation as a framework, because the framework's flexibility absorbs any result. Only specific models die, and the family always survives the funeral. Turok's Ptolemy jab lives exactly here, and it must be said that the jab cuts. Epicycles also fit every observation. That was the problem. Advantage mirror decisively in the category that defines what science is. And yet, the mature counterpoint, flexibility is not fraud. Frameworks earn their keep by organizing research, and inflation has organized 40 years of triumphant precision cosmology. Popper's razor is one value among several. The scale still tips, but hold it with both hands. Completeness and maturity. Inflation is a fully developed apparatus, perturbation theory to arbitrary order, reheating models, numerical pipelines, thousands of workers, every Planck analysis run through its formalism. The mirror is young and visibly unfinished, the perturbation derivation contested, the quantum treatment of the singularity open by the author's own admission, beyond the scope of this letter, the Volovic objection unresolved in print, the 2 sigma amplitude strain acknowledged and unexplained. Advantage inflation, and not narrowly. A challenger that has not finished its homework cannot claim the chair, however elegant its opening moves. Before I read the total, try the referee's chair yourself. Set the 2 theories side by side in your mind and ask the question a scientist must ask before any loyalty. Which one would be easier to prove wrong by Friday? Take a genuine moment with it, because your answer to that question is your philosophy of science, whether you knew you had one or not. If you prize the theory that could die by Friday, you have sided with the wager. If you prize the theory that has survived 40 years of Fridays, you have sided with the track record. Both are defensible. The field itself is split along exactly that line, and now you know precisely where the split runs.
Now count the card. Smoothness and flatness, even. Tilt, inflation, narrowly. Amplitude, inflation, narrowly. Gravitational wave silence, mirror. Dark matter specificity, mirror. Global balance, no contest possible. Falsifiability, mirror, decisively but with a held breath. Maturity, inflation, clearly. Where does that leave an honest referee? Exactly here. Cosmic inflation remains the established working paradigm, the account that currently fits the full sweep of precision data with the deepest developed machinery, and nothing tonight dethrones it. The CPT-symmetric universe is not the new champion. It is something rarer and, for the health of the field, arguably more valuable. A genuine contender, built from nothing but known physics, that has put its entire life on numbers the next decade of instruments will read. This channel's verdict, stated without hedging, the evidence today favors inflation as the description and the mirror as the discipline, the theory whose exposed organs are forcing the whole field to make its wagers explicit. Science advances on challengers rigid enough to die. It has one. And the referee's docket for the next decade is already printed. So let me read it out, because you will live through these results. Next-generation polarization experiments at the South Pole and in orbit will push the limit on R towards 0.001. A detection at any level ends the mirror. A continued silence starves inflation's natural models toward their own quiet crisis. Euclid is flying now, Rubin is scanning now, and between them the neutrino mass ledger will close. A massless, lightest neutrino is a loud vote for the mirror. A measured mass is a wound it may not survive. The curvature bracket will shrink onto the discrete menu or away from it. PUEO will fly over the ice and either resurrect the strangest anomaly in astroparticle physics or bury it in glaciology. Not one of these is hypothetical. This is scheduled science, and the mirror has bet everything on all of it at once, which is either the shortest route to the graveyard or the fastest road to Stockholm that any cosmological idea has taken in your lifetime. And because you will encounter these results as headlines, let me arm you to read them. If you ever see the words, primordial gravitational waves detected, that is the mirror's obituary and inflation's coronation. Full stop, no appeal. Check that the detection survives the dust analysis that killed the 2014 claim, then update accordingly. If you see the lightest neutrino has mass, the mirror is gravely wounded. If you see cosmic curvature measured non-zero, pull up the discrete menu, -0.016, -0.011, -0.004, and check whether the number landed on it. A hit would be the strangest headline of the century hiding in a technical paper. And if the years pass and the headlines simply fail to arrive, no waves, no neutrino mass, curvature flat, understand that silence is itself data.
quietly compounding in the rigid theory's favor, while the flexible one pays no penalty and claims no credit. Most viewers of this video will live to see at least 2 of these questions closed. Very few stories in physics hand the audience the scorecard in advance. This one has. Before the last turn, a moment of personal honesty, because this is the part that stays with me, and it is not the anti-universe. It is the refereeing. Turok declining the ANITA trophy that would have crowned his own theory. The 2 sigma amplitude strain printed by the very authors it embarrasses, next to the sentence, "We have yet to verify our assumptions." The peer reviewers extracting a public work in progress before letting the papers through. Whatever becomes of the mirror, the file of this theory is a masterclass in how the machine is supposed to work. Bold claim, named prices, published wounds, scheduled executions. When I first read through this literature, that was what I had to sit with for a while. Not the reflection at the beginning of time, the candor. So now, the pocketed question. Does the anti-universe have to exist as a real place for any of this to be true? You have heard Turok's own answer. It need not be real in the classical sense, just as your image in the mirror is not real. It may be a mathematical device that keeps the initial condition honest. Notice what that concession does and does not surrender. Every prediction you have weighed tonight, the dark matter giant, the silent gravitational wave sky, the massless neutrino, the curvature menu, follows whether the far sheet is a world or a bookkeeping entry. The physics is indifferent to the metaphysics. And there is something almost unbearably fitting in that, because it is exactly how your bathroom mirror works. The reflection is not a second room, yet the optics that put it there are real, exact, and testable, and no account of the light in your room is complete without the image in the glass. The anti-universe may be that kind of real, not a place you could visit, but a structure the equations cannot close without. Here the science reaches its true edge, and it is honest to say so plainly. Whether the Big Bang was an absolute beginning, a mirror, a rounded pole, or a bounce in an unending chain, no dataset in existence can yet decide. Whether there was a before is, tonight, a question physics has learned to ask precisely, but has not learned to answer. And beneath every one of these frameworks, inflation included, mirror included, sits the question none of them touches: why there is a universe to be symmetric about anything at all. That question stands beyond what any measurement on any docket can settle, and this channel will not pretend otherwise in either direction. The equations run through the singularity. Whether anything else does, no one knows. What you have walked through tonight is the full case, CPT symmetry, the one exact reflection in physical law, elevated from a property of particles to a proposed architecture of everything. The Big Bang recast from a wall into a two-sided boundary. An anti-universe, real or mathematical, balancing our matter with its antimatter. A dark matter candidate named to the decimal, born of gravity and silence. And a wager, r equals 0, that the sky is grading in public. Neil Turok and Latham Boyle may be wrong. The referees of the next decade, polarized microwaves, weighed neutrinos, measured curvature, will say so if they are, and the theory has arranged its own affairs so that a wrong answer cannot be survived. That arrangement is the deepest respect a scientist can pay the universe. If you found value in this exploration, consider subscribing. It helps these deep dives reach more curious minds. Tomorrow morning you will stand at the glass again, and the person looking back will be, as always, reversed and unreachable, and obedient to every law you obey. You have never once believed the reflection was another room, but you have also never once caught the mirror making a mistake. Perhaps the beginning of time deserves the same double respect. Not a wall where everything ends, but a surface where everything balances, the universe and its opposite holding each other steady across a boundary neither can cross. You are lopsided alone. The glass completes you, and if the mathematics is right, the cosmos itself has been standing at that mirror for 13.8 billion years, matched, balanced, and symmetric at last.